Hello and welcome to this lesson on conditions for fermentation. In today's lesson, we will explain the role of sugar, nutrients, and their availability in supporting yeast fermentation. Learn the optimal temperature and pH ranges for yeast fermentation, and understand the significance of anaerobic conditions in the fermentation process. Finally, we will look at the distillation process used to purify the alcohol produced. So far, you've become familiar with the process of fermentation and how aqueous solutions of ethanol are produced when sugar solutions are fermented using yeast. Building on this foundation, today's lesson will advance our chemical understanding by exploring the specific conditions under which yeast fermentation is most efficient. Let's get started. Yeast requires a sugar source to carry out fermentation. Typically, yeast is introduced into an aqueous solution containing dissolved sugars. As we mentioned in the previous lesson, this makes the sugar accessible to the yeast and allows the yeast to move around freely, leading to more effective metabolization of the sugar. Beyond sugars, yeast requires essential nutrients to sustain growth and carry out fermentation. These nutrients include nitrogen sources, such as amino acids, as well as vitamins and minerals. Proper nutrient availability ensures that yeast can reproduce, maintain cellular functions, and handle stress during fermentation. Temperature plays a crucial role in yeast fermentation. The optimal temperature range for yeast activity is between 25 degrees Celsius and 35 degrees Celsius. Within this range, yeast cells can efficiently metabolize sugars and perform enzymatic reactions. If the temperature is too low, yeast activity slows down, resulting in a less efficient fermentation process. Conversely, if the temperature is too high, yeast cells can be damaged or killed, stopping fermentation altogether. Therefore, maintaining a moderate temperature ensures that yeast can thrive and produce alcohol effectively. The pH level of the fermentation medium is another critical factor. Yeast performs best in a slightly acidic to neutral environment, typically between pH 4 and pH 6. These pH conditions help maintain the functionality of enzymes involved in the fermentation process. If the pH is too low or too high, enzyme activities can be hindered, leading to inefficient sugar conversion. Therefore, ensuring the pH stays within this optimal range supports the metabolic processes of yeast. Fermentation must occur under anaerobic conditions, meaning in the absence of oxygen. Yeast cells switch to anaerobic respiration when deprived of oxygen, enabling the conversion of sugars into ethanol and carbon dioxide. In contrast, in the presence of oxygen, yeast would favor aerobic respiration, producing water and carbon dioxide instead of alcohol. Maintaining an oxygen-free environment ensures that yeast prioritizes alcohol production. To achieve anaerobic conditions during fermentation, the setup typically involves using a sealed container with a delivery tube connected to a test tube containing lime water. The sealed container prevents oxygen from entering, while the delivery tube allows carbon dioxide gas, produced during fermentation, to escape into the lime water, preventing pressure buildup. By keeping oxygen out, the yeast is forced to perform anaerobic respiration, thus producing ethanol and carbon dioxide. By understanding and maintaining these optimal conditions of temperature, pH, anaerobic environment, and sufficient nutrients, we can significantly enhance the efficiency and yield of alcohol production through yeast fermentation. A well-controlled fermentation process maximizes the effectiveness of yeast, leading to better alcohol content and consistent results. After fermentation, the ethanol produced is mixed with water, yeast cells, and other byproducts. To make the ethanol purer, we use a process called distillation. This important step helps us separate ethanol from the other components, which makes the alcohol more concentrated and suitable for different uses. Distillation works by taking advantage of the different boiling points of ethanol and water. Ethanol boils at 78 degrees Celsius, while water boils at 100 degrees Celsius. By using this difference, we can separate ethanol from the mixture effectively. Now looking at the process, the fermented mixture is placed in a distillation flask and heated. As the temperature increases, the ethanol evaporates first because it has a lower boiling point than water. The ethanol vapor then passes through a condenser, which is a piece of equipment that cools the vapor using circulating cold water. This cooling process turns the vapor back into a liquid. The condensed ethanol is collected separately in a receiving flask. leaving behind most of the water, yeast, and other impurities in the original container. This process results in ethanol that is much purer, although there might still be some water left, creating an ethanol-water mixture. To get completely pure ethanol, more advanced methods like fractional distillation would be needed. But simple distillation is enough to show the main ideas behind separation techniques at this level. Distillation not only increases the alcohol content, but also removes other unwanted byproducts that could affect the quality of the ethanol. This method is commonly used both in laboratories and industries to purify liquids based on their boiling points. Distillation must be done carefully because ethanol is flammable. Proper lab safety rules and supervision are very important to avoid accidents. You should always use the right kind of heating equipment and make sure there are no open flames near your setup. Also, working in a well-ventilated area helps reduce the risk of inhaling ethanol vapors. In today's lesson, we delved into the optimal conditions for yeast fermentation, crucial for efficient alcohol production. We learned that yeast thrives in an aqueous, nutrient-containing sugar solution. We also learned that the ideal temperature range for yeast activity is between 25 degrees Celsius and 35 degrees Celsius, where enzymatic reactions occur most effectively. Additionally, yeast performs best in a slightly acidic to neutral pH range of 4 to 6. We also highlighted the significance of anaerobic conditions. Yeast must ferment in the absence of oxygen to produce ethanol rather than water and carbon dioxide. Understanding these conditions allows us to optimize the fermentation process, enhancing both alcohol yield and consistency. Finally, we looked at the distillation process that purifies alcohol by using the different boiling points of water and ethanol. Watch the rest of the GCSE chemistry course at Sophos Education.